Hello guys, welcome back to the stock market analysis in Python course. We're going to be continuing with our linear regression machine learning model, and this is where we are as of now. We are predicting the stock prices of ICICI Bank, and we have done our EDA, we've defined our features. Now we are going to be starting with implementation of linear regression. Now what we'll do is, the first thing would be to define our label. So I'm going to be using label as the target price because I want things to be predicted 30 days down the line. Now, which reminds me that I also need to have two things in place. So one would be forecast. I'm going to be calling it forecast out. So I want this 30 days out, or forecast down, or forecast out, whatever you call it. So 30 days out, and my forecast column, or let's just say call, is equal to label. Now df label. So what I need to do now is define my forecast. Okay, so forecast column is actually going to be adjusted close. So I'll run this, and I'm going to be using that adjusted close and forecast out. So df forecast call. So this is what I need, but I want this shifted by, now I want a negative because I want my data set to go down by 30 rows and then bring it back up. So bring it back up is like shifting 30 days up. So minus forecast out. Now this is just a little weird. Let's just call it duration. Yeah, that OCD was kicking in. Now control V. Now this duration is not defined. Why is duration not defined? I just defined it. Now this is what we have. Let's just quickly see what df is right now. So right here we have label prices. This is what we are targeting at, guys. This is what we want. So knowing these features, I want to predict this. Okay, sounds like a task. Now remember one thing, guys, linear regression is never going to make you rich. So this is for practice. This is to get accustomed to machine learning. This is to know what machine learning and what machine learning is and how linear regression works. But linear regression is too basic a framework to make you rich. But I mean, we always want to know how good linear regression can do. So we have the df label. So we've defined the label. What we're going to do now quickly is we're going to drop all NAs because we'll have a lot of NA, especially the first 30 rows. So let's quickly df dot drop NA in place equals true. Why do I always do this? Yep, I know. Right. Oh, I know it's setting the copy. I should probably set a handler that ignores these warnings. Right, so now starts the classifier, because this is where we define our x. So x is going to be my features and y will have my target. So y is going to be the label. So df label is my y, right? And x is, so what I want is np.array, because df Now I also want to drop, so x is everything but label, so let's just do df.drop, and I'm going to be dropping label, and I want the whole column to be dropped, so it's going to be 1. So this is just the syntax, nothing great. What I've done here is just dropped label, and the remaining has become my x. I've converted that to numpy for my regression model. Similarly, I'm going to convert this to a numpy array, df label. This is it. Okay, so now what I want to do is I want to be pre-processing this data and scaling it, because you don't want various scales to be treated in the same data frame, because your data set will unnecessarily emphasize more on larger scales, and you do not want that, because you want every feature to be in a single range. Now what this pre-processing is going to do is okay, here it is. Now pre-processing will bring down everything in the same scale, and this is usually done by mean normalization, which is a very basic concept. You divide every value by the range, and that basically just brings down everything to -1, in the range of -1 to 1, and that basically simplifies things for your regression model. Accuracy goes up, just some best practices. So what I'll do is I'm going to make it, so this has to be a data frame, so pd.dataframe, and what I need is so what I want to do is pre-processing on scale on x, so x is going to be pre-processed and y should remain the same. So copying that and pasting it here. All right, so we've defined our features and the target variable. Now features are the independent variables, and target variable is the label, the value that we are trying to predict. That's the dependent variable. Right, so let's run the classifier, and before that I'm going to, so x train, x test, actually y train and y test. So these are my data sets, and what I'll essentially do is I will call train test split. So train test split is used for it's like a cross validation, but mostly here it is. So what it does is it is used for dividing your data set into training and testing data sets, and that is going to help you first train your data set, and then you'll be able to check, basically test how your model has performed using this particular data set. So it's a validation method, and x, so this is just a simple syntax, x, y, and I'm going to be also giving the test size here. Now I want, so this is a fraction, so I want 20% of my data to be tested, so only 80% is going to be used for training and the remaining for testing. So classifier is going to be linear regression. This is actually the best part, because all you need to do if you want to switch your model from linear regression to, let's say, SVM is, have we imported SVM? We have. So we're going to actually test this. So we're just going to change this particular line to SVM, and it's as simple as that to switch your machine learning model. Trust me guys, it's really simple. Now clf.fit and x train and okay, ytrain and clf.score is going to use x test and y test. Let's just call this accuracy for the time being. And what do you guys think? Before I run this bit of code, what do you guys think the accuracy of this particular code will be? Now, I'm trying to predict stock prices for ICICI Bank 30 days down the line using this historical data, and 83% accuracy. Now, to be honest, this is not very bad, but this can get better. This can get better. I wonder how it'll be. So why I had changed this to be a separate variable and I did not hard code it here was because I wanted to be able to change this to see how it works. Now, duration 15, I'm just going to quickly run all of this. And now let's see what the accuracy is. So it was 83.51%. Now it is 94.4%. So you are 94.4% accurate in predicting your share prices. How many days down the line? 15 days down the line. Okay, I wonder how it'll be if I switch to 10. Now this step is annoying me, so I'm going to make a function out of it in the next video. 96.49, 96.47%. now this is something. This is not bad. Okay, so what's coming to my mind now is that what if I do not want the exact price, but I want to know whether my next day will be a bullish day or a bearish day. So I can just make use of a duration equal to 1 and run a logistic regression on it. Oh my god, so 99.5% accurate with my next day's prediction. And this is impressive of linear regression as a very, very basic model, guys. Now you can with 99.5% accuracy predict your next day's prices. Now I don't see how that's not going to make you money, because people say linear regression never, and that's what I said, never gives you money. It cannot make you rich, but I think it's a decent model to start with. We are going to have a lot of other models too. We are going to be able to, as I said, use logistic regression, but apart from that, we are going to be using training strategies. And we're going to be implementing and backtesting those strategies in Python, and that's where the fun starts. So thank you for watching this, guys. All the best. Try running this and make sure you win something and not lose. Do subscribe to my channel for more very, very cool videos. I have a lot of other projects also, and this is one of the first machine learning algorithms that I've run. And if you guys are excited, do like, subscribe and comment. Thank you.